everyone, welcome back. So today we will discuss security identifier in Active Directory. So before start the session, let me ask you a simple question. Imagine your company has two employees with exactly the same name. Let's say both are named as Rahul Sharma. Now one works in HR and other works in finance. If both employees request access to the finance folder, how does Windows know which Rahul should get access? So it cannot rely on names alone, right? So that's exactly why Windows use something called a security identifier or SID. So in today's video, we will understand what a SID is, how it's created, why it's important to Active Directory, and how Windows uses it behind the scenes in every single day. Okay, so let's start. So let's understand with very basics. What is a SID? A security identifier or SID is a unique value assigned to every security principal. Now you might be wondering, what is a security principal? It's a simply any object that can be given permissions. That includes users, computers, and security groups. Think of a SID like your Aadhaar number or an employee ID. Your name might change. You might even move to another office. But your unique identification numbers remains the way the organizations recognize you. So Windows works exactly the same way. The moment an account is created, Windows generates a SID for it. And here is something important. Even if that account is deleted, Microsoft never reuse that SID. Okay. Now here is something that surprised many people. When we log into Windows, we type a username. We think like Windows is using that username to identify us, right? But that's exactly not true. Windows only uses the username to help you log in. Once authentication is complete, Windows completely switches to using your SID. Let's go back to our Rahul Sharma example. Suppose you delete Rahul's accounts today. Tomorrow you create another account with exactly the same name. Even though the name looks identical, Windows see it as a completely different person because a new account retrieves a brand new SID. That's why old permissions don't automatically come back. Now let's understand what SID actually looks like. Here SID is made up of different parts. So the first part comes the revision number. This tells Windows which version of the SID format is being used. And the next part is identifier. It identifies the authority that issued the SID. Then comes the domain identifier. Finally, the last number is called the relative identifier or RID, which like uniquely identifies the account. So you can think of it like a postal address, country, state, city, house number. Every part helps Windows locate one unique security principal. Okay. Now let's decode a real SID together. Here you can see S -1 -5 -32 -544. Don't worry, you don't need to memorize it. Let's break it down. Here revision 1 means it's using version 1 of the SID format. Authority 5 means it was issued by NT authority. And 32 represent the built-in domain that exists on every Windows computer. And finally, the RID 544 identifies the built-in administrator group. So once you know how to read SID, those long numbers suddenly become much less difficult and confusing. Right. Now let's look at a real example. How we can see the domain admin SID. You will notice something different. Instead of small number in the middle, you will see a large sequence. That large sequence is the unique identity of your Active Directory domain. So the every domain in the world has a different domain SID. Then Windows simply adds RID at the end. For example, RID 512 always represent the domain admins group. So you can think of SID like this. Domain identity plus account numbers equals the complete SID. Okay. Now let's understand the RID allocations and the RID master. In our large organizations, you might have several domain controllers. All of them can create new users. So how do they make sure they don't accidentally assign the same ID? That's where the RID master's FISMO role comes in. Think of it like a bank issuing tokens books to different branches, and each branches gets its own range of token number. Since every branch has different range, no duplicate tokens are issued. The RID master does exactly the same thing with RID. Okay, so it issues the RID values for each component. So now let's understand the difference between SID and GUID. Like most of the people often confused SIDs and GUID, but they serve different purpose. SID is used for security. It's what Windows uses when checking permissions. And a GUID is used to uniquely identify the object itself inside Active Directory. Think of it this way. Your employee ID is used when entering the office. Your password number, your passport number identifies you globally. Both identify you, but for different purpose. Okay. Now let's understand the SID history. Imagine your company merges with another company. Your account is moved into a new Active Directory domain. Since you are now in different domain, Windows create a brand new SID. So what happens to all your existing permissions? Do administrator need to manually update every folder? Thankfully, no. Windows store your previous SID inside an attribute called SID history. When you log in, Windows include both your new SID and your private and your previous SIDs in your access token. That's why you can continue accessing resources without administrator rebuilding all of your permissions. Okay, so that is the SID history. Now let's look like SID that are always the same. So not like every SID is unique. Some SID are exactly the same on every Windows computers in the world. These are called well-known SIDs. For example, everyone, authenticated users, systems, anonymous login, enterprise domain controller, administrator. So Microsoft keeps these value constant because Windows component rely on them everywhere. No matter which organizations you are working on, these well-known SIDs never change. Okay. So here is some most important RIDs value. So you don't need to memorize 100 of RID values, but there are few that every Active Directory administrator should know. RID 500 is always the built-in administrator count. 501 is guest. 502 is the KRBT data counts used by Karuros. 512 represents domain admins and 519 represents enterprise admins. If you ever see these values in logs or security investigations, you will immediately know which accounts or groups Windows is referring to. Okay. Now let's see the capability SID. So the modern Windows also introduced something called capability SID. You have probably experienced this without realizing it. When an application asks for permissions to use your camera or locations, Windows checks whether the application has the required capability. If it does, access is granted. If not, access is denied. So capability SIDs allows Windows to control exactly what resources and applications can use, improving both security and privacy. Okay. Okay. Now let's quickly recap. Let's summarize everything that we have learned today. So every user, computer, and security groups receive a unique SID. Windows Trust SID, not names. Each SID contains a domain identifier and RID. RID values are managed by the RID master. SID history preserve access after migrations, and well-known SID remain the same on every Windows system. So understanding SID helps explain how Windows makes security decisions behind the scenes. Okay. And that's the security explained from start to finish. I hope this video helped you understand not just what SID is, but why Microsoft designed it this way and how it is used every day in activity. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and let me know in the comment sections which activity topic you'd like me to explain. Thanks for watching. I'll see you in the next video. Thank you. Bye bye.